Hello. Okay, so today we're working on lab number 10, which is factors that affect the rate of reaction. And we're discussing 4 major factors, one being concentration, which is how much of a chemical is in a given solution. We'll be exploring that and how that affects the rate of reaction. The next is temperature, and then we have a catalyst, as well as surface area. So let's start right off with concentration. For this, as well as for the temperature lab, we are taking out again our baking soda and our vinegar that we used during the double replacement lab. And we're going to be mixing them together at different concentrations. So this first part, we'll be measuring out some baking soda, measuring out some vinegar, and then changing the concentration. So for our experiment that explores concentration, what we're going to do is again the reaction with baking soda and vinegar that you used in our double replacement lab. We're going to be using a concentrated solution and a diluted solution to see how quickly vinegar can dissolve a 1/4 teaspoon of baking soda. So hopefully you can find a 1/4 teaspoon measuring device at home. If not, you can use a 1/2 teaspoon or something similar, but make sure you note down how much you're using. Okay, so we're going to be measuring 1/4 teaspoon of baking soda. But first, let's take our vinegar. What we need is 50 milliliters of vinegar. And a good way to measure is to pour it into a second container, because this big jug is hard to maneuver. So I'm going to use this small container and get down to eye level and measure 50 milliliters so I can see the meniscus on the 50 milliliter mark at eye level. Okay, 50 milliliters of vinegar, put the top back on, and I'll take a 1/4 tablespoon of baking soda. As accurately as you can measure that. So, I'm going to be dissolving this into the vinegar, and I'm going to be timing how long it takes while I'm stirring it for all of the baking soda to be used up. And I'm using just my phone to time it. Any other timer would work as well. So as soon as I put the vinegar in here, I'm hitting start. All right. And you can see it fizzes. That's our expected reaction. Fizzing all over my paper. I'm going to keep mixing it until all the baking soda is used up. If you remember what our products are, carbon dioxide and water. And sodium acetate. Okay, so that took about 40 seconds or so. I'm going to write down exactly the point where I hit stop. 43 seconds. You can measure this to the nearest second. Mine's going to the nearest 100th of a second. But because of human error, the end point is going to be a matter of judgment anyway. So the nearest second is good enough. Okay. So this was 100% vinegar, 50 milliliters of vinegar and a 1/4 tablespoon of baking soda. Now the next one we're going to try is a dilution of this. So I'm going to use only 25 milliliters of vinegar with 25 milliliters of water added to it. So this is diluted. There's going to be half water, half vinegar. And you can think, do you think that that's going to react more strongly with the baking soda or less strongly? And if it's less reactive, will it take more time for me to dissolve all the baking soda into that, or will it happen more quickly? Let's find out. Okay, so I'm going to take this sample, get rid of it. I had more baking soda sitting there. And I'm just going to rinse this, and we'll start our diluted experiment. Okay, and now we're going to try this same experiment with our diluted vinegar. So we need a total of 50 milliliters again, but it's going to only be half vinegar and half water. So that's how we dilute our solution. So I'm going to measure 25 milliliters of vinegar. Actually, I still have some in our secondary container. We'll get down to eye level and measure 25 milliliters of vinegar. And I do need just a little bit more. So I'll take some out of our larger container. Put it here. That was about 20 milliliters. I'm just going to add a little bit more. 25. And finished measuring the 50 with 25 milliliters of water. So always measure liquids by pouring very slowly into the container. Overshooting can be more frustrating than just doing it slowly the first time. Then you'll have to start scooping some out with water or pouring it out of the container, and that can be challenging. Okay, so we're going to add our 1/4 teaspoon of baking soda. I may have said tablespoon last time. It's a teaspoon, which it says here is also equal to 1 milliliter. And we're going to time how long that takes to completely dissolve in this diluted solution of vinegar and water. Now, do we think our diluted solution will be more or less reactive than the concentrated solution? And if it's going to be one or the other, does that mean it's going to take more or less time? So let's find out by testing it. Again, with our stopwatch. As soon as I add the baking soda, I hit start, and I'll start mixing and dissolving. We're going to stop once the reaction is complete and all the baking soda is gone. Last time it took 43 seconds. Still hearing fizzing. If you stir it and you hear fizzing, it's not quite done. Okay, I'm going to call that done. That took 1 minute and 3 seconds. So which one dissolved the baking soda more quickly? The concentrated vinegar that we used in the first experiment or the diluted vinegar that we just used? Well, the concentrated vinegar dissolved all the baking soda in 43 seconds. The diluted vinegar took about a minute to dissolve all of it. So the diluted solution went a little bit slower because within our same volume of solution, there were less acetic acid molecules, acetic acid being the vinegar. So we can say that a more concentrated solution causes a faster reaction. A faster reaction between the baking soda and the vinegar occurred in the concentrated solution. You can try that yourself, see if you come up with the same solution. I look forward to seeing your results. Also make sure that you're filling out your data sheets and submitting those online, as well as a picture or a video showing your outcome. And the next experiment we'll do is testing the effect of temperature on the reaction rate.